Hi everyone, welcome back to my channel and I hope you guys are doing extremely well. So in this video we will discuss about flood fill algorithm and we will solve this problem. So without wasting time, let's get started this brand new topic, which is flood fill algorithm. So before moving forward, let's understand the problem statement quickly. So the problem is quite simple, that we have a 2D grid. As you can see here, we have a 2D grid, and where each cell represent a color, you also have some starting pixel. Let's say it's as starting row and starting column, and now our task is to change the color of the starting pixel and also change the color of its connected pixel, having the same original color into the new color. That means, let me explain all the things in very simple manner so that you can get it easily. Okay, suppose our starting pixel is this. That means SR and starting row and starting column is 0, 0. So what we need to do, we need to change the color of this particular node as the given new color. Okay, suppose the new color is 2. So what we will do, we will change it to 2, and also we need to check whether its adjacent node have the same color as its original color. That means its original color is 1 and we need to check whether its adjacent node, that means we need to check upward, downward, left and right, and inside from this node there isn't any kind of left node, there isn't any kind of upward node. So what we need to do, we need to check for right and downward. As if we can see here, in right, the right node of this particular starting pixel is 1. It means it's same as its original color of that starting pixel. So what we need to do, we need to change its color also, and also we need to check for this particular downwards node, and we need to check whether its color is same as original color. Yes, it's 1. So what we need to do, we need to change it to 2, and also what we need to do, we need to also check for this particular node's adjacent node. That means we need to check for its neighbor node. That means we go here, we will go here, and also we will change the color of these two particular node, and so on. That means we need to change the color of the connected components, connected nodes of this starting pixel if the starting color of all the nodes are same as original color. That's the problem statement. I hope you got understood the problem statement in a very simple manner. So let's move toward the intuition and let's see how we can think about this problem, how we can solve this particular problem. So let's move towards intuition. So let's think step by step. That means, suppose when you click on pixel in a pen tool, suppose you have seen pen tool, okay, in your laptop. So when you click on any pixel of that pen tool, it doesn't change that one particular pixel. It changes the color of that whole pixel inside that pen tool. That means it spreads to all neighboring pixel that have the same color. That means if, wait, this, suppose this is a pen tool and this is the starting pixel, and also this is the pixel, this is the pixel, this is the pixel, this is the pixel, and that have the same color as starting pixel. Then what we will do, when we change the color of this particular pixel, then it will spread itself to all the connected neighbors of its. Okay, that's the simple intuition. So, and when we change its neighbor, then it will spread itself toward its neighbor, then it will spread itself towards its neighbor, and so on until and unless we cross the boundary limit. That means if and whenever it satisfies the boundary condition, then we need to change the color of that particular pixel. So that's what our intuition behind it. That means how we can approach this problem. So now if you can observe carefully, be attentive, okay, observe carefully, each cell can be treated as node. Yes, that means it is the node, it is the node, it is the node. Okay, and we can move in 4 direction. That means, suppose let's work only on that particular one single node. that means 0 comma 0. So we can move in all the four direction. Let me if we have to check for all the four direction, then the best node is this 1 comma 1. Okay, so we can move from here, we can move from move towards all the direction from this particular node. Okay, we can go upward, we can go downward, we can go left, we can go right. So suppose its original color is 1, we need to change it as new color. Suppose new color is 2, so what we will do, we will change it and we will check for its adjacent node. That means we will check for its left side node, its right side node, its upward node, and its downward node. And also what we need to check, whether it's all the adjacent node have same color as the original color. Okay, so that's what you can think for this particular problem. So if you observe it very carefully, then this problem is of graph traversal. So what we can use DFS or DFS. In the previous problem that was rotten oranges, we used DFS. So in this problem we will use DFS. So we will master DFS in this video, and you will definitely understood how DFS works during real interview problem. Okay, let's coming to the approach, what we will do. Okay, let me erase all this thing, and after that we will move towards approach. Suppose we need to store original color somewhere. So suppose the given thing will be starting row. As you can see in problem statement, the given thing will be starting row, starting color, and new color. So suppose the name of this particular grid is image. So the original color will be image of SR and SC. Take a variable name. Okay, we will move towards and we will definitely move towards try run as after we think of after we thought of approach. Okay, so now what we need to do, we store our original color in variable original C. Okay, now if the original color is already equal to the new color, that means the original color is, if the original color is already equal to new color, then we need to return this particular grid. Suppose if the original color is 2 and the new color is also a 2, then what we need to do, we need to simply return this image. No need to do anything. After that, we will start DFS from the given cell, and that means, let me write all the things. We will start DFS for the given node. Okay, and check if it is inside the grid. Check if it has the same original color. If yes, then what we will do, we will change its color to the new color. Then we move in all the four direction, that is upward, downward, left, and right, and keep repeating this process recursively. That's it. That's it. That means that's our approach for solving this particular problem. So what we need to do, let me summarize all the things, and after that, what we need to do, we need to store the original color of that particular node. Okay, and after that, what we will need to do, we will check whether the original color is already equal to the new color. If yes, then we need to return this grid. Otherwise, that means we don't need to do anything. Otherwise, we will call DFS from the given cell. For every cell, we need to check if it is inside a grid, check if it has the same color as original color. If yes, then we need to change the color and then move towards all the four directions, and keep repeating this process. Okay, so that's the approach for solving this particular problem. So let's start dry run. That is very important concept. That is very important thing for understanding this particular problem. Okay, let me resolve this thing, and after that we will move towards dry run. Okay, so what we'll need to do, suppose we have this grid and SR is equal to n and SC is equal to 1. Okay, and suppose our new color is equal to 2. This is the given thing in this problem statement. Okay, firstly what we need to do, we need to store that original color. So what will be the original color? Original color will be that color which is given, which is at starting row and starting column. So take a variable original color and this will be image of SR and SC. Okay, which is equal to here, which is equal to 1. 1 comma 1 is 1, so that's why the original color is 1. Okay, check whether, we need to check whether the original color is equal to new color. New color is 2 and original color is 1. No, it's not equal. So what we need to do, original color is not equal to new color, then what we need to do, we need to call DFS for starting row, starting column, grid, new color. Okay, that means starting row, starting column, that particular grid, new color, and the original color. Now let's start the execution of this DFS function. Starting row is, let me enter all the things. Okay, yes, we need to call this DFS. So we need to check a boundary condition, whether this row and column is greater than 0. Yes, it is greater than 0. Whether it's less than equal to n cross n comma m. Yes, it is. Whether the original color that means our original color is not equal to that particular new color. No, it's not. That means it is a valid condition. So what we need to do, we need to change the color of image SR SC to new color. What is the new color? New color is 2. That means the array, the grid become G1. This will become 2. Wait. This is 1 now. Okay. Now the grid will become like this. Grid will look like this. Okay, so what we need to do, we need to check in all the 4 direction of this particular. We will go upward, we will go downward, we will go left, and we will go right, and we will need to call DFS for all these. That means for going the wait, the current row is 1 and the current column is 1, so we need to call DFS for row minus 1, row plus 1, column minus 1, column plus 1. So what we need to do, we will first call DFS for row minus 1, that will become 0, column, image, new color, and original color. And also what we will do, we will call DFS for row plus 1, that is 2, column, image, original, new color, and original color. Also we need to call DFS for row, column minus 1, grid, new color, and original color. Also DFS for row, column plus 1, grid, new color, and original color. So we need to call DFS for all these in all these 4 directions. So let's call DFS for all these 4 directions. Firstly we will call DFS for this. So what we will do, we will go that means it will go and make this one 2. How? This is very simple process. What will it do? It will go here and make it 2, as similar as this. That means here we will check the boundary condition, that is it is greater than equal to 0. Yes, it is greater than equal to 0. It is, column is also greater than equal to 0, row is less than equal to, wait, what we need to check, firstly we need to check whether row is less than equal to 0. That means row should be greater than 0 or equal to 0, column should be greater than or equal to 0, row should be less than equal to n, column should be less than equal to m or less than m. Okay, that's what we need to check. It satisfy all this condition, so we will change the color to 2. Also when this will this DFS is completed, now it's time for this. And what will it do? It will go in and check for the second row. It's 0, it's not equal to original color. So what we need to do, we need to return. That means we don't need to do anything here. Now it come here, that means here 1, 0, it will change its color. It will change its color to 2. Okay, now it will go check upward, check downward, check left, and now it will go towards right. Right is not equal to the original color, that means we don't need to do anything. Now it's done. It's done for this particular node. Okay, so it's done. Now what we need to do, if it is done, we need to call DFS for this node. That means this will, now the color is 2, so what will it do? That means if we call DFS of 0, 0, then what will do, it will make it 2, it will make it 2, it will make it 2, but we can't reach here, so it will not make it 2. That's done. That means after completing first iteration, these three become 2. Okay, now coming to the next one. Let me erase all this thing. After that we will move towards. Okay, this will work as similar. That means as this make this one 2, this will make this one 2 as same as this. Okay, so I'm not going to explain you all this thing. Let me write the code, and after that we will check whether the code is working fine or not. Okay, so let me come to my ID, and after that here's what our ID is. I need to write a DFS function. So let me write a DFS function first for it. What I need to do, I will take I and j, that is row and column, and what I need to do, vector of vector int ampersand image comma int new color and int original color. Okay, now we need to check a boundary condition. If I is less than 0, or j is less than 0, or I is greater than equal to image dot size of row, or j is greater than equal to size of column, image 0 dot size. Wait. Okay, so what we need to do, we will simply need to return. Also we need to check for, why is this? Okay, also what we need to do, we need to check for if image of I and j is not equal to original color, then we need to return. Now what we need to do, image of I and j equal to new color, and also call DFS in all the 4 direction. Okay, that's what it is. So let me call DFS in, suppose, new color, take it as input, call DFS. Okay, that's cool. Let me run it once and check whether it's working fine or not. G++ YT. Okay, what's the fault? Okay, image, this will be image. G++. Oh, fault. It's my fault. G++ YT. Okay. Let 3 cross 3. Okay, let's write 1 1 1 1 1 0 1 0 1. Take new color as 2. Yes, that's what our output is. Our output is totally correct and our code is working fine. So I hope you understood this overall concept of flood fill algorithm. So if you understood this problem, your graph basic is just got stronger. Before you leave, try solving this once you're on without looking at the code. That's how you will actually master it. In the next video we will solve 0-1 matrix problem where we all use multi-source DFS. So make sure you subscribe so you don't miss it. See you See you in the next video.